Hello, Algebra 2 students. This is the first video I've made for you guys, but I wanted to give you a good explanation of 8.2 without just giving you a worksheet, so here we are. Excuse me. What I'd like to do with this video is give you some notes to take, and so the objectives we're going to go over with this video are simplifying radicals, and we're going to talk about how to break them up into factors of perfect squares. We're going to multiply radicals, and we're going to talk about how when we multiply radicals we can only do that with radicals of the same index. And we're also going to divide radicals, and we're going to do that largely by rationalizing denominators. So let's get into this video. Excuse me. And I want to be very clear about my expectations from you for this video as well. When I write anything down, you should be writing that down in your notes. You should have your pencil ready, you should have a piece of paper out, and you should be taking notes just like we would in class. If your notes are not an accurate tool, it's going to be very hard to help yourself on an assignment. So you have to make sure that you are writing down everything that I do. Okay, with that being said, let's get started. The first example I want to do with you guys is one about multiplying. So we're going to say example, and then we're going to say multiply, because that's what we're told to do. And let's say that we were given square root 13 times square root of 2. And notice how these are both radicals of the same index. This is a square root, this is a square root, so I am allowed to multiply them together. And here's what I can write next. I can write this multiplication underneath one radical, and I can say 13 times 2 underneath one radical. And from here I can simplify to 13 times 2, which gets me 26, and I'm done. Radical 26 is my answer. One more for good measure, write this one down too. Let's say I had cube root of 5x squared times the cube root of, let's say, 2y. Now again, I noticed that this is the same index, right? A cube root and a cube root. So I am allowed to do this. I am allowed to write one big cube root and multiply both of these inside. 5x squared times 2y. And now we should remember for multiplying monomials together that this simplifies to be the cube root of 10, and then I can't do anything with x squared and y. I just have to write them again in that cube root, and that is my answer, the cube root of 10x squared y. And that is essentially how you multiply radicals together in a very simple sense. Let's talk about simplifying next. So let's say we were given the radical. Let's say we were taking the square root of 48x to the 5th. And what we're going to do here is what our objective said at the very beginning. We're going to break this up into factors of perfect squares. So here's what I mean. I really don't get to do much with the square root of 48. That really can't be changed. It's just the square root of 48. Unless I think of it as a perfect square times something else. So 48 is not a perfect square. However, 16 is. So what I can break 48 up as is the square root of 16 times the square root of 3. Because 16 times 3 is 48, and now you can see I've taken out a perfect square. And I know in a second that's going to simplify to something else. And next, I do the same thing with this x to the 5th. I know that x to the 4th is a perfect square variable. So I'm going to break that up as x to the 4th times x, because x to the 4th times x is x to the 5th. And again, I know this is going to simplify to something. So when I first simplify radical 16, I know that's going to be 4 And I'm going to cross that one out. Now that I'm done with it, I'm going to cross it out from my list of factors here because I know I simplified it already. And then I'm going to deal with the square root of x to the 4th. We talked about yesterday how you can take the power and divide by the root. So 4 divided by 2, that's going to become x squared. And now I'm left with two things I cannot simplify. The square root of 3, can't do anything with that, and the square root of x, I can't do anything with that. Those won't simplify at all. So I have to write them in a radical still. Square root 3x, and this is my final answer. Here's another way to think about it, to kind of double check whatever you're thinking. Excuse me. Remember, your calculator is pretty handy at this stuff too. And if you do the square root of 48 in your calculator, square root 48, it will give you 4 radical 3. So it would give you the fact that this became the 4 and the radical 3 couldn't be simplified. Your calculator does that part for you. However, you're going to have to be in charge of simplifying your exponents for your variables as well. Alright, let's do another one of those. Let's say I had the cube root of 108 y to the 8th z to the 9th. I'm going to handle this in much the same way, except this time I'm not going to be looking for perfect squares. I'm going to be looking for perfect cubes because I'm dealing with a cube root here. So what I can break 108 into is a perfect cube of 27. So I'm going to say the cube root of 27 times cube root of 4, because 27 times 4 is 108. And then I'm going to break this up as cube root of y to the 6th times the cube root of y squared times, lastly, the cube root of z to the 9th. And here's why this makes sense to break up the variables in this way. When you are breaking your variables up into perfect cubes or perfect squares, you need to pick numbers that are divisible by your root. So I chose to break it up as y to the 6th because 6 divided by 3 is going to be 2. That's going to work out for me. 9 divided by 3 is going to be 3, so the z is going to work out as well. Again, my end game there were numbers that were divisible by 3. Over here, I broke it up as x to the 4th because I was dividing by my root 2, and 4 is divisible by 2, so that's why that one worked. But here, I'm picking numbers that are divisible by 3. So, now that we have everything written out that will eventually simplify, let's take care of each piece. I know that the cube root of 27 is going to get me 3. And now that I've written that out, I'm going to cross it out. And I also know the cube root of y to the 6th is going to be y squared, so I'm going to write that as well. And lastly, I know the cube root of z to the 9th, 9 divided by 3 is going to be 3, z to the 3rd. Okay, and now that I've stayed organized, I've crossed all those 3 out, so I know the only thing I have left under a cube root are 4 and y squared. So I'm going to write that. I'm going to write my cube root here, 4 y squared, and I am done. Excuse me. Sometimes we're going to have to multiply and then simplify, like in these next problems. Let's say we had the example. We were told to simplify, and we had the square root of 8x squared times 12xy squared. What you should first do here, what I recommend doing, is multiplying everything together under one radical first. I recommend doing 8 times 12, which should get you 96, x squared times x, which would be x to the third, and lastly, y squared at the end. Now, I recommend you take this and you simplify it in the way that we just did in the previous examples. Let's break up 96 as radical 16 times radical 6, because 16 times 6 is 96. And a quicker way to find these multiples is to take the number 96 and just start dividing it by perfect squares. Start dividing it by 4, by 9, by 16, by 25, by 36, and just keep dividing by perfect squares until you find the biggest one that fits in there. And then use that perfect square and put it as a factor because it will simplify. Next, I'm going to turn x cubed into square root x squared, right, because that's going to simplify, times x. And lastly, I'm going to leave it as the square root of y squared because that will also simplify. Have my little equal sign there as well. And now, I'm going to simplify each piece, and as I do, I'm going to cross out what I simplified. I know that radical 16 is going to become 4. I know that the square root of x squared is going to become x. And I know the square root of y squared is going to become y. And I'm left with square root of 6x. And I'm done. Alright. Moving on down here. Let me just shuffle my papers around. Thank you for your patience there. Okay. Let's practice simplifying when things don't start out very neat, when things aren't automatically grouped for us. So let's say we had the problem 7 times square root 8x times negative 1 square root 3y to the fourth. And this brings us to another one of our objectives. When we're multiplying radicals together, we should group like terms. So we should group, or like factors, pardon me, because these are factors, not terms. And so what I mean by that is taking the regular numbers, 7 and negative 1, multiplying those together. So let's write that out. 7 times negative 1. And then taking the two radicals, 8x and 3y to the fourth, and multiplying those two together separately as well. Radical 8x times radical 3y to the fourth. Now we have something that's a little bit easier to look at. I know 7 times negative 1 is going to be negative 7. And I know this radical, I can make it one big square root. 8 times 3 gets me 24. And then I have x. And I have y to the fourth. Now there is some simplifying I can do with that radical, so I am going to take care of that. I know that radical 24 can be broken up as the square root of 4, which is my perfect square, times the square root of 6. I know I can't do anything with square root x, I'm just going to write that again. And y to the fourth is also a perfect square that's going to break down. So now that I have everything written out, I'm going to start rewriting everything simplified. I know I still have my negative 7 out front. And then I do times. I know that radical 4 just becomes a 2, and now that I took care of it, I'm going to cross it out. Can't do anything with the radical 6. Can't do anything with radical x. But square root y to the fourth, remember that's 4 divided by the index 2. 4 divided by 2 is y squared. And I still have, underneath the radical, right, what I couldn't simplify, 6 times x. 6x. Excuse me. And so I simplify just a little bit more on the outside. Negative 7 times 2 is going to get me negative 14 y squared radical 6x, and now I am done with that. So again, the key strategy there is multiplying your like factors first, right? Regular numbers and then your radicals. Okay, and make sure you always simplify at the end. And one more time, I'll show you. If you're having a hard time visualizing and knowing that you're correct with simplifying these radicals, remember that your calculator always does the number part for you. Remember, if I just do square root 24, it would have already told me that that was going to be a 2 and a radical 6. Right? It already took care of that part of our answer for us. So you can always double check that part in your calculator, and I really encourage you to do so. Alright, let's move on to another type of example. Let's next talk about dividing. Let's say we have a question that asked us to simplify that looked like this. Let's say it was radical 125 over radical 5. The first thing you should do whenever you have a radical over a radical is rewrite it as one big radical. This is a property of radicals that is totally allowed. If you have a radical over a radical, you are allowed to make it one radical and one fraction. And if you see where this is going, this fraction now inside here, 125 divided by 5, can actually be simplified. 125 divided by 5 is actually 25, so I still have the square root, but now I have 25 in there, and we see where this is going. The square root of 25 is just going to get me 5. And that would be my final answer. Again, the strategy there was creating one radical when I had two separates. That's important. Let's do one more of that. Let's say I start with radical 128 over radical 4. Once again, my first step is one big radical and one fraction. I take care of my division. 128 divided by 4 gets me 32. So I have radical 32. And now I can simplify this. Again, your calculator takes care of that, but I encourage you to challenge yourself and to think about what perfect square fits into 32. And the answer is 16. Radical 16 times radical 2 is what I can break that up as. The square root of 16 is going to get me 4, and then I still have my radical 2 on the outside. And I'm done with that one as well. Alright, lastly, let's talk about rationalizing the denominator. Rationalizing the denominator. So let's say I had the following. Again, we're going to give ourselves the title, Rationalizing the Denominator. And now let's go through an example. It tells us to simplify. We're given a radical 15x squared over a radical 5xy to the third. Excuse me. So, what's next here is what our second step was in the last two problems. When you have a radical over a radical, you should make one big radical and one fraction on the inside. And there we have it. And what you should start to see, given our prior units on polynomials and dividing polynomials, along with our rules of exponents, is that 15 over 5 is going to get me a 3. That this, I'm going to cross that out and write it to the way that I've shown you in class. I'm going to cross out 15 over 5. I'm going to write a 3 on top, because that's what happens. 15 over 5 is 3. I'm also going to cross out my x squared over my x, right? 2 on top, 1 on bottom. I cross 1 out, and I'm left with 1x on top. Cross that out with me. And then on the bottom, I'm left with that y to the third, which I can't really do anything with. So I'm left with this big radical, 3x on top, y cubed on bottom. Now, what we have here is a problem in algebra. What we have here is a radical with a denominator, and we can't have that. We can't ever have this situation going on where we have a radical in the bottom of a fraction. It's just not very neat to have in algebra. It's not something we call fully simplified. So what we do to simplify it is we multiply top and bottom by whatever the radical in the bottom is. So I'm actually going to use my other marker here. Or pen, I should say. Anyway, I have really a radical y cubed here, so I'm going to multiply the top and the bottom by that same thing, by radical y cubed. And here's what's going to happen. On the bottom now, I'm going to have y to the 6th, because 3 plus 3 is 6. And on the top, I'm going to have 3xy to the 3rd. And now I'm going to take care of a few things. I'm going to rewrite this again as 2 separate radicals, and I'm going to tell you why in a second. I'm going to rewrite the top as the square root of 3xy cubed all over the square root of y to the 6th. And now we can see pretty clearly on the bottom that this can be simplified. What we did to the bottom of our fraction was we created a perfect square. And so now if I take the square root, I take my power 6 divided by my index 2, 6 divided by 2, and I get y to the 3rd on the bottom. And on the top, I can start to break this radical up so I can simplify it. I can do radical 3 times radical x. Notice how those don't simplify, but look what happens when we get to y to the 3rd. I can break that up as y squared times y. And now I've given myself a perfect square that will simplify here. Excuse me. What I can do now is I can take this square root of y squared, which gets me just y, and I can put that on the outside. And I cross it out, and that's the only part of my numerator that can simplify. And now I have 3xy that I still have to write in the radical. So I'm going to write that, 3xy, all over y to the 3rd. Now I take a look at that for a second, and I see there's one more thing I can simplify. Now I have a y on top and 3 y's on bottom, which means if I cross one out, I have 2 left on the bottom. I have y squared left on the bottom. And so I write the whole new answer as square root 3xy all over y squared. And I'm done. Let's do one more type of example with rationalizing the denominator, and then I'll leave you alone. Okay, so let's go over an example that looks like this, where again I'm asked to simplify, but this time my fraction looks like this: radical 3 plus radical 11 all over radical 6. Now I want you to recall from the last example what we multiplied top and bottom by. In the last example, we multiplied the top and bottom by the radical that was in the denominator. And that's exactly our first step here as well. That's what rationalizing the denominator means. You multiply by whatever radical is in the bottom, top and bottom. So that's our first step. Let's write that in. We multiply top by radical 6 and bottom by radical 6. And here's how we manage that. On the bottom, first of all, radical 6 times radical 6, really cool things happen. We can visualize this as radical 6 times 6, right? Radical 36. But then the square root of 36 is just 6. Another way to think about it is that when you have a radical of one number times a radical of the same number, the radical goes away, and you get just the number that was underneath it. So in short, radical 6 times radical 6 is just 6. And on the top, what I'm going to use is that good old distribution property. If I have one term multiplied to 2, it's going to look like this. Radical 6 times radical 3 plus radical 6 times radical 11. And now from what we've learned earlier about multiplying radicals, I know that I can simplify both of these terms here. And I can make it radical 18 plus radical 66 all over 6. And again, your calculator can manage these two pieces on its own, but I want you to challenge yourselves here and think about what perfect square fits into 18. The answer there is going to be 9. So we should break it up as radical 9 times radical 2 plus what you may have found out already if you used your calculator is that radical 66 can't be simplified. There are no perfect squares that fit into 66, so we leave it as just radical 66. And of course, we still have our denominator of 6. I do some simplifying here. I know that radical 9 is just 3, so I get 3 radical 2 plus radical 66 all over 6. And that is all I can do. I'm done. Okay, that is my video for you guys. I do want to refer you to page 362. What you'll find there is more examples. There are different examples than I just did in this video that explain things in a little bit of a different way, so please feel free to look there. There's more than one way to go about this. So if you want to see another way to do these problems, that's a great resource. And other than that, you guys are ready for your assignment, so thank you for watching.